Hi students, today our topic is relations, problem solving. Now the first one is r equals to x comma y, x minus y is an integer and x comma y which belongs to z. Now see solution. So check whether it is a reflexive or symmetric or transitive. If it satisfies reflexive, symmetric, transitive, so it is an equivalence. Now the first one is reflexive. Coming to the reflexive, so x comma x belongs to R for all x belongs to A. So what is our relation? X minus y is an integer. Now in place of y we have x. Now substitute x here in place of y. See what happens. So x minus x, which is equal to 0, is an integer. So clearly 0 is an integer, so it satisfies reflexive. Now coming to the symmetric. So if x comma y belongs to R, then y comma x also belongs to R. So he has given that x minus y is an integer. Now replace, interchange the values in place of xy. So y minus x is also an integer. So no problem with this. Why? Because so 5 minus 3, it is if it is an integer, 5 minus 3 equal to 2, it is an integer. Then what is 3 minus 5 minus 2? Clearly it is an integer, so satisfies. So it satisfies symmetric also. Now coming to the transitive. So what is transitive? If x comma y belongs to R, y comma z belongs to R, then x comma z belongs to R. Now see, so clearly he has given x minus y is an integer. For suppose y minus z is also an integer. Then now clearly x minus y is an integer, y minus z is also an integer. Now add these two, x minus y, it is an integer, plus y minus z, it is an integer. What we get? X minus z. So integer, so plus integer. So integer plus integer, what we get? Integer. So clearly x minus z is also an integer. So it satisfies transitive also. So it satisfies reflexive, symmetric and transitive. So our given relation is equivalence. Now the second one is, so r equal to a comma b, a less than or equal to b square. So where a comma b belongs to R. So clearly real number. See what is given, the relation a less than or equal to b square. See, coming to the reflexive. So what is reflexive? Reflexive says that a comma a belongs to R. So coming to the reflexive, what is reflexive? A comma a belongs to R. So in place of b we have a. So that we can replace with b with a. What we get? A less than or equal to a square. So because a comma a belongs to R. So R means here the relation. Here R means real. Now a less than or equal to a square. So it satisfies for all negative and positive integers. But coming to the fractional values, for suppose if I take a equal to 1 by 2, then what we get? So 1 by 2 less than or equal to 1 by 4. Is it true? No, it is false. So clearly it does not satisfy fraction values. So what has given? A comma b belongs to R. For every real, this condition should be satisfied, but it does not satisfy a equal to 1 by 2. So fractional values, if you substitute fractional values, so it is not satisfy the given. So the given condition is not satisfied, so it is not reflexive. Reflexive is not satisfied here. Now coming to the symmetric. So what about symmetric? If A comma B belongs to R, then B comma A also belongs to R. So clearly, for suppose, which means that A less than or equal to B square means that B less than or equal to A square. It is about symmetry. For suppose if I take two values, for suppose 1 comma 2, now here substitute here, so 1 less than or equal to 2 square, okay, no problem with this, but 2 less than or equal to 1 square, it is not possible. So clearly, so it is not symmetric. Now coming to the transitive, so A less than or equal to B square, B less than or equal to C square, then what we get, for suppose if it is transitive, we have this condition, but see here, A less than or equal to B square, and here B is what? C square. Now replace in place of B C square, what we get? A less than or equal to, for suppose here we have B square, what is B? C square. Now substitute C square here, C square whole square, then it is A less than or equal to C power 4. But what we get, coming to the transitive, if A less than or equal to B square, B less than or equal to C square, then it must be A less than or equal to C square. But what we have? A less than or equal to C power 4. So that it does not satisfy transitive also. So clearly it is neither reflexive, nor transitive, nor symmetric. So neither reflexive, nor symmetric, and nor transitive. And the next one is R equal to x comma y x square minus 4xy plus 3y square equal to 0, where x comma y belongs to n, which means natural number. Clearly, so what is reflexive says, so if it is reflexive, then x comma x must belongs to the relation for all x belongs to A. So now in place of y we have x. Now replace y with x here, what we get? X square minus 4x into y is what? X here, so 4x square plus 3x square. Now x square minus 4x square plus 3x square is what? Equal to 0. Now what we get? 0 equal to 0. So it satisfies reflexive. Now coming to the symmetric. So then if xy belongs to R, then y comma x also belongs to R. So now interchange x with y and y with x, what we get from this? So y square minus 4xy, no problem here, plus 3x square equal to 0. So what is our original equation? X square minus 4xy plus 3y square equal to 0. It is in terms of x and y, and it is in terms of yx. See clearly, so while we solve this, what we get? X equal to y and x equal to 3y. But here, similar way, what we get? Y equal to x and y equal to 3x. Now see here x equal to y, no problem with this, y equal to x, no problem. But here y equal to 3x, if you interchange this, x equal to 3y. So y equal to 3x and x equal to 3y, both are not equal. So that's why it is not said to be symmetric. Symmetric is not possible. Why? Because here y equal to 3x, but here x equal to 3y. Now coming to the transitive. So x comma y belongs to R and y comma z belongs to R, then x comma z which also belongs to R. See original, and then coming to yz, so y square minus 4yz plus 3z square equal to 0. Now what we get? Y equal to z and y equal to 3z. Now coming to the xz, x square minus 4xz plus 3z square equal to 0. Clearly what we get, x equal to z, x equal to 3z. Okay, now what is our original equation? X equal to y and x equal to 3y. So x equal to y, y equal to z, then x equal to z. No problem with this. So see here, x equal to y, y equal to z. So x equal to y, y equal to z, which means that x equal to z. So no problem with this. Okay for this. But coming to the next one, so here x equal to 3y, y equal to 3z, which means that in place of y what we have, 3z. Now replace with this. So clearly x equal to 3 into 3z, which means that x equal to 9z. But here what is x? It is 3z. But what we have, 9z. So both are not equal. That's why it does not satisfy transitive. So clearly it is not transitive. So it is reflexive. Why? Because it satisfies x comma y order pair, but it is not symmetric and not transitive. Clearly reflexive but not symmetric but not transitive.